Hey there, welcome back. On our last video, we have talked about synchronization, right? Now friends, when it comes to synchronization, there are three types of synchronization which are available to us. These are synchronized method, synchronized block, and static synchronization. Today we will talk about synchronized method. Now friends, the best way to understand synchronized method concept is via an example. So let's create a very simple example and we would be creating a new class. The name of the class would be like brackets. Alright, and inside this class we will be having one method. This would be a public method. And the name of the method would be like generate. Here we go. And inside this method we will generate a pattern of brackets. So in here let me add in a loop. This would be a for loop on a variable I. The condition would be I is less than equals to 10, I plus plus. Pretty cool and standard stuff, right? And in here we will add in a condition. If I is less than equal to 5, then in that condition we will print a bracket, and this would be like this, a opening bracket, and we will be making use of print, not println. So in every iteration a single character of bracket would be added if the condition is right. Else if the condition is false, we will type in or we will display the closing bracket, right? And after all the iterations in our for loop, what we will do is we will add on a sysout statement, and system.out.println will bring the cursor to the new line. So very standard and usual stuff. And inside of a main method, as if now, let me create an object of brackets. So I will type in brackets, bracket equals new bracket. All right, and let me call in the method. So I will type in bracket dot generate. A very usual and little weird type of program, right? So we are generating a pattern. Let me execute this, and as soon as I execute this, we are able to see some weird output because in here I have missed making use of print method. Now when I execute, now we will get a proper encode output. Pretty cool stuff, right? So let me get rid of this call to generate method, and now we would be creating two threads. Now friends, moving forward, let us hit couple of enters in here in order to give you a better view, and I will type in new thread dot start. So we are creating a thread, but where is the run method declaration? So in between the pair of parentheses of thread, we will type in new runnable, and here is our run method, and inside the run method we will again create one loop. So let me copy the loop declaration in order to save some time. Here we go. And this loop would be, for example, for 5 iterations. And inside this loop we will call in the generate method. Let me format this a little real quick. So in here I will type in bracket dot generate. All right, so now let me execute the program. This will give us a good overall output. Let me copy this particular part real quick and paste it once again. So here is yet another anonymous thread. Alright, so this looks good to me. Let me execute this once again, and somehow now things are getting little interesting. Now somehow there is some interference and we are able to see some unexpected output. Some unexpected output in every run. Now friends, why we are getting multiple outputs when we are trying to execute this program multiple times? The reason is pretty simple. We have two threads, and inside every thread we have this for loop. So both the threads are executing this for loop. Now imagine that when both the threads are executing this for loop, inside the for loop we also have some small little processing as a result. For example, thread 1 is printing this opening bracket character. By the time the thread 1 is printing this character, the thread 2 has printed some other character on the console because both of these threads are getting executed simultaneously. As a result, we are getting different output when we are executing this program multiple times. Now, who can control this output? Definitely no one. This output is definitely based on your hardware performance, your operating system, the scheduling, the JVM call. So the external elements are also affecting the output of the program, and definitely this is not a good deal, and we want to apply some restrictions so that we can get a consistent output. Now, what is the solution? Solution is pretty simple. We will prevent this generate method to get executed on multiple threads simultaneously. Let me repeat it once again. The solution is to prevent this method to get executed on multiple threads simultaneously. Now friends, as soon as I mark this method as synchronized, this method won't get executed in multiple threads. Only one thread can execute this method at a specific point of time. As a result, we will get a consistent output. Let me show you the output now. Now friends, if I execute this program like multiple times, like thousands and thousands of times, even then we will get a constant and a consistent output because of the synchronized method. Alright, so this is it. Now there is a small little but a very important thing. Let me show you this. Now friends, when we check these threads, inside these threads we are making use of a single object, which is bracket. Now for example, if we make use of local copy of objects or different objects, for example, let me make this as bracket 1. Let me copy this statement and paste it in here and make yet another object as bracket 2, and in thread 1 we will make use of bracket 1, and in thread 2 we will make use of bracket 2. Then what would be the output? Alright, so how this small little change will affect this synchronized method? Let me show you the output. Again, the program will start giving us some inconsistent issues, which is weird, right? The reason why as soon as we are making use of different objects we are getting these kind of inconsistent output, the reason is pretty simple. When we mark a specific element as synchronized, an intrinsic lock, a monitor lock would be applied. Now this lock is specific to objects. Now whenever we are making use of different objects, locks are on different objects. There are multiple locks. As a result, the locks are nullified and we won't be able to get a proper and consistent output. So friends, always remember this, that the synchronized block will apply a lock, and lock is derived by objects. As a result, your synchronized block or your synchronized method can get affected. So this is it for today's video. I hope you guys understood it. If not, please revisit this video, try to experiment a little bit more and you will get it. Thanks for watching.